Hi, my name's Danny Leybzon, and I'm an MLOps architect at Y Labs. So the title of today's talk is AI Observability. And the subtitle was originally how to fix issues with your ML model, but I realized that this was actually a little bit misleading, a little bit of a misnomer, because what I'm going to be talking about today is not how to fix issues with a machine learning model, but rather how to fix issues with a machine learning system. And if you're unclear on what the difference is, well, good thing you're tuning into the presentation. So let's start off by taking a look at this visualization made by Google as part of the really famous Hidden Technical Debt in Machine Learning Systems paper. As you can see, there's a bunch of squares on the screen. There's a data collection square, a configuration square, a serving infrastructure square, and there's one tiny little rectangle that says ML code. What this visualization is meant to demonstrate is that the machine learning model is actually a very small part of an entire machine learning system. Although a lot of conversations historically have been about machine learning models, about the model architecture, about neural networks versus gradient boosted trees and random forests, although a lot of the focus has been on training and deploying a machine learning model, in fact, there's a lot more to a machine learning system than just the model. There's the whole process of collecting your data, extracting features from your data, cleaning the data, taking those features and then passing them through some transformations, serving them to the model serving its results, being able to take those results and giving them to the user, and then monitoring all of these different services. That's not to mention all of the data pipelines that might be involved in getting data into the machine learning model. So as you can see, there's a lot more that goes into ML than just a machine learning model. And that's why I think it's interesting and useful to be able to talk about observability, not just for ML models, but for ML systems. And if you're unclear about what observability is and why you might need observability for your machine learning system, don't worry, we're going to be getting into this in today's presentation. So as you can see, we've got a few topics on our agenda today. I'm going to start off by talking about the need for ML monitoring, the need to be able to monitor your machine learning models in production. But then we're going to dive into the fact that monitoring isn't enough, that it takes more than just continuous monitoring to know whether your machine learning model is still performing well, if it's not performing, experiencing any kind of failure, if there's no performance degradations. And in fact, we're going to talk about how observability complements monitoring to enable you to solve problems with machine learning systems. So after defining our terms and explaining what observability is, we're going to dive into the secret to observability. How do we actually get there? What do we need to implement in order to get observability into our machine learning system? And finally, we're going to talk about what to do when a model degrades and kind of get more into the nuts and bolts of different processes that we can take in order to make sure that our machine learning models stay accurate and reliable and are still performing well in production. So let's start off by setting some ground truth, and that is that models degrade, right? You need machine learning monitoring because over time, machine learning models deployed in production get worse. They get worse primarily for two different types of issues, both issues related to data. One is a data drift issue, and this is talked about pretty extensively in the ML ops industry and in data science, right? When the real world changes, a machine learning model that's trying to represent the real world gets stale. You can imagine if you trained your model on pre-COVID data and then COVID hits, and all of a sudden the real world has changed and your users are acting differently, your model is probably no longer able to, model the real world effectively. So data drift is definitely a significant issue, but to be completely honest, and this is a little bit heretical, I actually think that the ML ops industry spends too much time talking about data drift and not enough time talking about data quality. Because honestly, from what I've seen in production, the majority of issues that cause machine learning models to fail in production are not data drift issues, but actually really simple data quality issues. And I'll dive into those a little bit more later on. But fundamentally, without monitoring for your machine learning models, you can only find out how your model is performing from your customers. It's only at the point that your customer comes to you and says, hey, why did you recommend this bell pepper when I was looking for a bunch of flowers for my wife? Or, when it recommends a crazy movie when all you were looking for was something for your kid to watch, it's only at the point that your customers are on Twitter or in your support channels telling you what's wrong, that you actually realize that there's a problem. Conversely, with monitoring, you can be proactive instead of reactive, and you can realize that there are problems before your customers become aware of them. Now, there's a lot more that can be said about machine learning monitoring and production, but that's not the focus of today's presentation. If you want to learn more about ML monitoring, I've actually given talks on this topic a few times. Feel free to just Google my name, Danny Leybzon, ML monitoring, and you'll see a host of different talks that I've given at different venues talking about the need for machine learning monitoring. But today we're going to go a step further than monitoring, and we're going to go, under the proverbial iceberg and see how observability is complementary to monitoring. So first, we need to understand where monitoring falls short. So with monitoring, you can know that your machine learning model's performance has degraded, but you don't necessarily know what to do about it. Now what? Monitoring helps you detect a problem, but it doesn't tell you where the problem is originating from, so it doesn't help you solve the problem. In order to actually solve a problem, you need observability. So to kind of understand how observability works in the modern machine learning and MLOps space, I think it's actually useful to take a look at the traditional CI/CD practices, right? In DevOps and CI/CD, there's this loop of release, deploy, operate, monitor, plan, code, build, test, and then release again. And as you can see, it's an Ouroboros or an infinity sign or a cycle, however you want to describe it. But the point is this isn't a linear process that has a discrete stop and end. Rather, it's a continuous process, thus the C in both CI and CD, that tells you that you need to continue to improve your application and continue to maintain its performance even after it has been deployed. Now, the same is also true, and maybe actually more so, for machine learning models. And the reason for that is machine learning models are fundamentally more maybe not non-deterministic, but more dynamic, because they operate on data and because they attempt to model the real world rather than having a fixed set of inputs like a classic software application would. But the model lifecycle is actually very similar to the CI/CD lifecycle, right? We want to build and then test and then deploy and then evaluate our machine learning models. And once we're done evaluating them, we can go back and build another one and test it and deploy it and evaluate it and continue the cycle to make sure that our machine learning models are, not just continuing to perform well and not just negating failure opportunities for them, but also improving them and continuously making sure that they're getting better. Which brings us to what is observability. So observability fundamentally is insight into the state of a system by looking at its outputs. What does this mean? It means that you're able to understand what's happening with an application or with any kind of system based only by looking at the things that it is producing. An interesting little aside, observability is definitely not unique to MLOps, and neither does it originate from DevOps. It actually originally comes from control theory, where in control theory, observability was not looking at a system as in a machine learning system or as in a software application, but really any kind of system that you might want to be controlling, like a mechatronics style robot or something along those lines. So observability importantly requires historical state, and this is especially the case of machine learning observability, because you want to be able to see how a system has changed over time. You need to be able to track its historical state in order to understand what's happening with your machine learning system now. And importantly, observability enables you to do postmortem and enables you to do analysis. It's really the key to debugging, the key to fixing the problems that have developed in whatever kind of system you have, but especially in machine learning systems. And the key to observability, the secret of observability is really quite simple. DevOps figured out the secret quite a while ago: logging. Logging can mean a couple of different things, but I'm using the term in kind of its looser definition here, where logging just means gathering the outputs of the system, gathering what's going on inside of the system. So it makes a lot of sense that logging is key to observability if we remember that observability is insight into the state of a system based on its outputs. So in DevOps, there's the three pillars of observability, these very classic types of logs, again, using the word log broadly, which includes metrics, traces, and logs in their narrower sense. So metrics are quantitative. They're numbers that represent stuff like your bounce rate or your CPU consumption, these numbers that represent something about a system. Traces are a little bit unique to microservices architectures and to the fact that more and more applications are being deployed not as singular monoliths where everything is happening in a single process, but rather as a bunch of discrete processes, which means that if you want to understand what's happening in your system, you need to understand and be able to trace the output of a system through the various subcomponents of the system. And then logging and logs in the most narrow definition is a unstructured output of an application, something that gives you some kind of qualitative information rather than quantitative information about what's going on inside of that system. So we've got our three pillars in software 1.0, but what about in software 2.0? What about for machine learning systems? Well, machine learning systems have some different requirements than software 1.0 systems, right? As I alluded to earlier, software 2.0 systems are more dynamic. They change because they are trying to represent the real world, and the real world is also changing, and because their inputs are dynamic as well, because there's not a fixed set of inputs. There are a bunch of different types of inputs that people can have. It just so happens that the inputs for a software 2.0 system are specifically data, which means that being able to take logs for a machine learning system, for a software 2.0 system, means being able to log data. And I'm using data here in a broad sense, not only the input data, right? Not only the independent variables that I'm feeding to my machine learning models, but also the output data, the predictions or the inferences that are being made by my machine learning models. These are also a type of data, as well as performance data, right? The ground truth that tells you what's actually happening in the real world, and then the performance that you're able to infer based off of the difference between your output data and the ground truth data, if you have access to ground truth. As a quick aside, people oftentimes come up to me after these types of presentations and ask, hey, I don't have access to ground truth, so I don't know in real time what the performance of my machine learning model is. Does this mean that there's no point for me monitoring or trying to get observability for my machine learning system? And the answer to that is absolutely not. Like, if you have input data and you have output data, these will be sufficient in at least giving you some understanding of what's happening in the system. And I actually think that it's irresponsible to not be monitoring that input and that output data, even if you don't have access to ground truth. Interestingly, there's a lot of very cool research being done, and even a couple of commercial applications happening with the ability to generate ground truth in its absence based on inferring changes in input data and output data. So, stay tuned on that. I'll probably be giving a presentation comparing different academic methods for generating ground truth in their absence. But just for now, keep in mind that it's still useful to talk about observability and monitoring, even if you don't have access to ground truth, and therefore you don't have performance data right out of the bat. And here's a graphic that we're going to come back to later in today's presentation, but that I really want to emphasize. Like, if there's one thing that I want everybody to take away from this presentation, it's that AI observability, right? Like the ability to get insight into the state of a machine learning system actually is not squarely in the field of ML ops. It exists truly at the intersection of data ops and ML ops. And the reason for that is that a machine learning system is not only the machine learning model at the end of the system, it's the entire system around the machine learning model, including the data pipeline leading up to the machine learning system. And in order to get monitoring and observability for your machine learning model, you need to be getting monitoring and observability for data as it flows through the entire system. So this need for logging for ML systems and for logging for data is exactly what motivated us to build YLogs. So YLogs is the open standard for data logging. What it does is it creates the types of logs that we would want for an observability and a monitoring solution. YLogs is, again, totally open source. Basically, what it does is it takes in data, and that can be like your input data, your output data, your ground truth, your performance data, whatever kind of data, and it creates statistical summaries of these data sets. It creates these artifacts that are called profiles. And the cool thing about these profiles, about these statistical summaries, is that you can track them over time. You can, even using YLogs, you can compare them against each other, and you can see how your data has changed, both your input data as well as the performance of your model. And what's really powerful about this is that the ability to analyze the historical state of a system by looking at the logs of the system enables you to get the kind of monitoring and observability that we've been talking about. YLogs have some really cool properties. They're descriptive, which means that they tell you a lot about the data set that they're summarizing. They're very lightweight, which means that it's super easy to store them, move them around, process them, and they're mergeable. Mergeability is its own, entirely really interesting presentation that I could give. But basically, you can take two YLogs profiles, combine them together, and as a result, create an entirely new profile that represents both of the previous profiles. This might sound a little bit abstract, but it has some really cool applications in terms of being able to monitor distributed systems, like if you're using Ray or Spark or Dask or Modin, any of these systems for doing distributed compute on machine learning. It also allows you to monitor streaming systems. So if you've got like Kafka or Kinesis, you can generate YLogs profiles based on those streams because of this property of mergeability. Okay, so we've talked pretty abstractly about the need for observability, how you can get to it with logging. Now I want to talk a little bit more concretely about what can you actually do if your machine learning system degrades. Well, I'm going to present to you two different workflows for how you can resolve problems in machine learning systems. There's a human in the loop process and an automated MLOps process. So the human in the loop process is pretty straightforward. So we've got our model in production, it's generating logs. We're putting these logs in some kind of observability platform, right? Somewhere that machine learning engineers can access them. This observability platform can send an alert to a machine learning engineer, right? Because it's doing monitoring. So the machine learning engineer can then go back, perform analysis on these logs, and get some kind of insight, right? Let's be a little bit more concrete. Let's say we've got like some data drift occurring. The machine learning engineer can go in and say, oh, I'm seeing drift on this feature that represents the number of bananas that somebody's buying in the store. Okay, people are buying different amounts of bananas. How is this impacting my model? Oh, it looks like my model is getting worse because of this. Okay, so I need to retrain my model based on the differences in how many bananas people are buying. Great. Now the machine learning engineer can take their insight and can remediate the problem with the model in production. So let's break down what happened here a little bit. The human in the loop here, the machine learning engineer, can analyze the cause of system degradation. They can figure out, is it a data quality issue, a data drift issue, and go on from there. Going on from there means taking some kind of remediative action, be that fixing a broken data pipeline, retraining a model on new data, whatever it might be, and then they can rinse and repeat and get notified the next time the model breaks. Okay, this is a fine way to go about this, but I think it's not the most interesting approach. Because I think, and this is getting a little bit philosophical, but as machine learning engineers, we really sit at the intersection of two fields that are the most poised and the most impactful at automating things, right? Classic software engineering with Software Eats the World was able to automate a lot of rote, repetitive activities that people used to have to do by hand, but that it was easier to be able to automate with software engineering practices. Machine learning similarly tries to automate the decision-making process, right? It tries to make it easier for machine learning systems, for the applications or the systems that are serving machine learning predictions, to be able to make decisions or to be able to make decisions based on data. So these are both forms of automation. And if we're going to be automating, everything with machine learning, then shouldn't we be automating the machine learning as much as possible as well? So what I'm going to be presenting now is a system for automated MLOps. So here we've got both our data pipeline, which is passing logs to our AI observability platform, and it's passing data to the model in production. Now, this model in production is also generating logs, right? As it's making predictions, it's serving those predictions to some application, but it's making logs that are also going to the AI observability platform. Now, let's say something happens, again, some kind of data drift or data quality problem. The AI observability platform can send an alert, but instead of that alert going to a human, it can go to some kind of intermediary process, something that will interpret this alert and, using at most simplistically like a series of if statements, say, if data has drifted, then I should retrain my model. Or if I have a data quality problem, then I should roll back my pipeline. So, this intermediary process is really key because it can take in an informational alert and translate that into some kind of action that needs to be taken. Again, this brings us back to AI observability sitting not squarely within MLOps, but at the intersection of data ops and MLOps, because in order to be able to automate this process that we were just seeing, it's not enough to get observability into the model in production. You need to get observability into the data pipeline as well. So just to quickly overview what we saw with automated MLOps, it really takes the human out of the process. It allows you to automatically trigger a rollback or automatically trigger a retraining, depending on what the right thing to do was. So that wraps up the bulk of today's presentation. I hope you enjoyed it. Despite the fact that this is a remote conference, I want to give people the opportunity to get some swag. I know this is something that I've really been missing from in-person conferences. And I imagine you guys could use some fresh t-shirts or like a cool stress ball or a mug. So in order to get some swag, it's actually really simple. You can just go to the ylogs project. You can Google us or go to bit.ly/ylogs and give us a star on GitHub. We just released our V1, so check out the new APIs and performance improvements that we have along with that. You can join our community Slack by going to bit.ly/ylog/slack. And then finally, if you've done both of those things, you can go to bit.ly/ylog/swag and send the relevant information, like what GitHub user did you use to start the project, what was the email that you used to join our Slack, and then if you want swag, we need an address to send it to, so give us your address as well, and we'll be able to send you some swag. Thanks for taking the time to listen to my presentation. If you're interested in ylogs, please, again, check out our GitHub, join our Slack, and you can reach out to me, Danny, either by email, danny@ylabs.ai, on Twitter @DLEYBZ, or on LinkedIn, where my name is just Danny Leybzon with a little mountain emoji at the end of it. Thanks for listening to today's presentation. If you've got any questions, hopefully you've already been asking them in the Slack channel, but if not, I will be available in the Slack channel to answer any kind of questions for you. Thanks again, and have a good rest of your day.